Okay, and now I think I'm going to talk about the last postulate. And this is the number 5 is the collapse of the wave function.
Sir,
Yeah,
I sort of had a question regarding
sure.
postulate number 3, which I've been meaning to ask.
Yes,
Uh,
please.
about the Klein-Gordon equation, about why it fails a quantum mechanical equation. I mean, one of the reasons why it fails is obviously because it's relativistic in nature, but like I'm sort of unaware about the other reason. I mean, it wasn't the quiz. I kind of got it wrong.
Right, it's actually not the relativistic nature. What it is that, in postulate 3, we are saying that the probability interpretation is related to this, the equation of continuity, where rho is given by psi star of psi, right? This is for Schrodinger equation, this is this expression. And see that this is a positive definite quantity, right?
Right.
So that means that rho has an interpretation of probability density, right? So for the Klein-Gordon equation, you can still derive an equation of continuity. But see that the Klein-Gordon equation is second order in time. As a consequence, for the Klein-Gordon equation, what you find is that the expression for rho is given by something like, there is some constant factor, is given by d by dt minus d psi star by dt times psi. So you see that this is not necessarily positive definite. In fact, you can find very easily, very like solutions of the Klein-Gordon equation where rho is not, rho is negative actually. So if rho is negative, that means that you cannot express this. You cannot, even though you have the equation, which is like this, you cannot express rho as as probability, right? Because it's not positive.
Because it's less than 0, right?
Yeah. Now, what it turns out in the Klein-Gordon equation, it turns out that this is the expectation value of this equation expresses charge conservation. Okay? Mm-hmm. So it does have an interpretation, but it's not a probabilistic interpretation. So this equation does have a quantum interpretation, but not in quantum mechanics. It has an interpretation in quantum field theory, okay? Which is another layer of abstraction that we have to, add to quantum mechanics. So the Klein-Gordon equation doesn't make sense as a quantum mechanical equation, but it does make sense as a quantum field theoretic equation, in which case the expectation value of this equation becomes an equation. So, what becomes is that the expectation value of this equation, this is a number. It doesn't have to be positive in this case, but it becomes charge density. And we know that charge can be both positive and negative. So this is just becomes a statement of the conservation of current, conservation of charge. Okay?
Right, sir.
Okay, very good. Okay, any other questions? Please ask questions. I mean, I don't mind any question, okay? And you shouldn't either.